Welcome to Simulation and Prototyping. This is the third tutorial for kangaroo2, and we're just working through a successive number of steps. And so I'm going to pull, so if you didn't watch the previous tutorial, maybe you should, because I'm just going to pull from the existing list of components so that we can accelerate the process of building these. And so I'm going to make sure that our Boolean toggle is set to false. So we'll leave this here. I'm going to hide the output. And let's copy it. We're going to swap out some of these components and we're going to work in a slightly different way. But it'll be better to see this as a manipulation than anything else. So, and maybe I'll even just work on a different layer. I'll hide my previous layer. This time around, rather than setting geometry above and letting that fall down, I'm going to start on the ground and basically inflate a surface to be kind of maybe a compression surface. So we'll start with a planar surface. I'm just going to fill the courtyard space with a planar surface. We can set our surface container with this one surface. So that's there. I can hide both. Hide it in grasshopper and hide it within rhino. And we have a mesh surface. Actually, let's turn on our solver. And we can even just reset it. So now we have our mesh flat on the ground. We have our deconstruct mesh. We can leave that there. We do not need our partition list this time around. We're going to model it a slightly different way. But let's delete our partition list and all of these items, all of these list items that are there through the middle. We are this time going to use mesh edges, which is a useful tool. So let's grab mesh edges, and this will take our mesh, and this will allow us to access either interior edges or the naked edges. Naked edges are the edges around the perimeter. And so let's see. Let's say geometry. See if we can just visualize these. And so the naked edge is around the perimeter, and the interior edges are all those obviously in the interior. But if we take both, then we have all of the edges from the entire model, or from our reference geometry. So let's do a couple of things. Let's swap out our loads and our edge lengths. And we started with one way with our catenary model, and we'll kind of revert to that for this time around. So for our goals, let's grab the load. And this time around, with the way that we load these, let's grab all of the vertices from the deconstructed mesh. We can load this into our merge, and rather than it being a minus or a negative number this time, we're going to use a positive number. So our force vector, which that's not liking so far, let's set this to be 0.5, so it's positive. And let's figure out what it's not liking. From text to vector. Interesting. Sometimes these accept it and sometimes they don't. Unless that's not the problem. I see the problem. It's not that it's the number, it's that we need to set, it's a vector. And so we need to set this as z. So it'll be positive 0.5 in the z distance, or in the z direction. And now that accepts that, and that moves through to there. So next, let's deal with our line lengths again. And so this is why we grabbed the edges, because they're lines and they have a dimension. So let's go up to goals, line, and we'll do length of line. These are, again, the output is the spring. And so let's bring in our geometry from both the naked edges and the interior edges. So all of the lines throughout our entire surface are going to have a spring. Let's set the strength. Well, we can leave it to 500. I think we may want to drop it, but we'll play with that in a second. And now let's capture or kind of analyze the length of our curves from all of those edges. Let's create a multiplication for this that will give us some way to control it. Maybe I'll even just pull this panel over, plug this into the multiplication, say 1.2. We'll see. We'll manipulate all of these numbers soon. Let's plug our spring into our merge. And then the one thing that we haven't done yet is to set our anchors. So in this case, let's start with, let's set some points. And to start, I'm just going to choose the 4 corners, and we can see what happens with this. Let's turn on our solver. We see it working. So what we have is a force applied in the positive z direction, which is a 0.5 force. This is really tall, but let's see if we change the force to be 1, we'll make it even taller. We'll stretch more of those elements. We saw more stretch occurring in the lower portions because all of the load, and again, the kind of tributary force applied to those. And maybe the strength of the spring, what if we set that to be 1,000? We see it stretching less. And maybe the multiplication factor, maybe we set that to be 1. That had a big impact on our surface. We can also hit reset, and we can watch it. It'll initiate from its first condition, the flat geometry, as opposed to where it was previously. So here we get a sense of it. We can hide a couple of things here. We can even hide the bouncy solver, turn on our geometry. If we middle mouse button, we can zoom selected. Doesn't always do a great job of zooming selected. And we're seeing the naked edges on the bottom. So I can hide those. We're seeing the geometry on the bottom. We can hide that. So now we have our surface, our mesh, that has a force applied from the bottom, moving vertically up. We've attached this down in 4 corners. But let's look at a couple of things. Let's do a couple of things with this. First off, what I'd like to do is, you saw how we set the points here, and that we set multiple points. So depending on how and where we do these, we can reset. So there's 4 different points that are set there. Let's do one more thing. And that is, what we were doing is we were just selecting the points based on this. If we want to feed it points, what we need to do is we need to make sure that these points align with vertices on our surface. And so what we're going to do is, let's see, let's hide our geometry for a second. And let's bake our mesh surface. And the reason, we're just going to bake it for a second, put it on the layer that I'm working on. Now what I can do is I can select points, or I can draw points in Rhino. And as long as I have my snap set to vertex, I can choose a set of points. And these points can be set there. Now that I have those, I'm confident that those points match the starting points that are at a vertex on the mesh. I can delete the mesh, because again, that was just a baked surface. But now as I get to anchor, I can set multiple points. Interesting, I thought I could window. That's my point. I can window as if I start that over. So now I selected all of those points. And let's feed those in to the point. I can delete this first point. What is it not liking? Huh. It's not working. You see that our surface is just floating away. I'm going to turn off the solver. Let's see. Doesn't even allow me to clear the points. I just never hit enter. Sorry about that. So those points should be set now. Let's reset. Let's initiate this. Now we see that those points are held and the geometry is allowed to lift up from there. What we can also do is, let's click on our point, and we should internalize the data. And then let's, I did this in the right order. I'm going to copy those same points and set them as a target. Now we can see as I highlight the target points, this will allow us to interactively manipulate them. And so as I select a point, I can pull it up. And so what these are, the anchor points are the starting condition. The target points allow us to set a final condition. I'm not sure why this one is not working over here. Seems to have missed the surface. You can reset. And so in this way, we can work with a kind of element that's being held down. It's working in every case except for that one over there. So let's try this again. It's just a relatively simple process, but what I like about it is that you should stop your simulation. Let's reset it. We can clear our points. We'll delete the points that we have there. Let's do the same thing. Let's bake our mesh. Let's draw some points. Maybe the one that I drew wasn't actually on a vertex, so make sure that and what we could do while we're here is let's turn off every other snap except for vertex. And even sometimes when I look at students' computers, sometimes near is selected. You should never, never, never have near as one of your snaps. So let's make sure that we're only snapping the vertex. I think I'm making points now, although I don't see them. All right, so there are a few points there. So now let's go, we'll make sure that's not selected. We'll go to the point container, set multiple points. We should be able to window. I selected the points, remember to hit enter. And then I can even just delete the target points, copy the points, set them to the target. And then again, we just want to internalize the data, which basically breaks its reference from somewhere else so that those points now are no longer parametric. And I can even delete the baked mesh. Let's turn our solver back on. And now we're missing one of those points. So it's a weird looking surface. Let's get to the point about just being able to use some of the edges, because we're going to do one more thing in this tutorial, which is to trim it as well so that we can have openings within there. So let's clear these values, clear these values. Delete those points. Let's reset. Let's bake the mesh once more. I'm just going to select some points or create some points along the edge. So here's the corner point. Just trying to find ways to hold this down. And then knowing that these can also be target points should allow us to set multiple points, enter, let's set multiple points again, enter those, and then let's internalize the data for both of them. Which will just make the processing a bit better. If that's internalized, let's initiate our solver. All right, so we've got this pretty well tied down. We're not really making enough space yet under here. So we could do a couple of things. We could increase our load factor in terms of pushing it up, or we could allow, let's see, 1.5. We could let our springs stretch a little bit more. So I think we went from 1 to 1.5, so maybe we'll try 1.2. I could also reset. That's looking pretty good. But let's do one thing. Let's turn on our target points and let's manipulate maybe just 2 points. Let's pull one of our corner points up. I'm going to pull one of these mid points down. Because the last thing I want to do is to trim this element, which will give us a much larger kind of opening or kind of courtyard within a courtyard condition with that. So we can hide those points. And my computer is not happy right now. And so we can turn the solver off. So it's not actively, it's basically paused. Hiding those. Now let's move all the way over to the right. So we have our geometry. Here's an example where we can take this geometry. Let's see, what we're seeing right now is the bouncy solver. This is the geometry of the mesh itself. And in this instance, let's do one thing. Let's pull the points from the mesh. So I'm going to create a point container. The I is the number of iterations that it took to solve it. V is the vertices or the vectors, both are V. And then O is the goal outputs. So in this case, I think what we can do is we can take the V and plug it into points. So now we get all of those points. I'm going to hide the geometry. So now we just have points. What I'm going to do is there's a really nice command called surface from points. So we can create a, not surface points, but surface from points. We can create a NURBS surface using the points from the mesh. And so what we need in terms of U count is, let's pull, remember the difference between the count and the actual things. So the U count, we can plug into our expression. It's going to be +1. So let's just then scroll all the way over to the right and plug this in for our U count. So now we have a nice NURBS surface from our mesh. We can turn our points off. And now maybe this will allow us to zoom selected better. It's a little better. So now we have a nice NURBS surface from our mesh. And I just want to trim that other bottom part. And so what I'm going to do with that is to, maybe even easier is just to draw the plane ourselves. Corner to corner. Zoom select on that. Now we're just going to move it up. Make sure that it intersects all the way through there, and it does. So why don't I do, let's see, a split B-rep. And so we need our surface B-rep. We need a B-rep container for our surface that we just set. Let's plug that into the cutter. We can hide both of these. We can hide this in Rhino. And now we can see that it did split it, but our B-rep result has 2 trimmed surfaces. And so let's grab the one that we want, which is list item. And we can toggle between those and see which one we want. A slider with 2 or 3 on there works. We can see 3 is greater than that. And so now we have a NURBS surface that we've trimmed. We've controlled some of those elements. We can bake this now if we want. And we could render it. Like that. And now we can go about our business within Rhino of working with that. So that is our next example. The last example, which we'll get ready to do now, just adds a couple of variations to this and allows us to add some additional forces. And so I'll explain how that works. Now's a good place to take a quick break, and then we'll start up again when you're ready. Let me know if you have any questions on this section, and we'll keep going. We're almost there. Thanks for hanging in there.